Hello everyone. Now I'll be showing keras Hub image tasks in four different levels: easy, intermediate, advanced, and expert. The easy task is like basic image classification on MINST dataset. So I loaded the dataset and only used a subset like 5,000 training samples and 1,000 test samples. Then I defined a model using custom layer called custom hub layer. So this layer wraps the MobileNet V2 classification model from TensorFlow Hub, and the MobileNet feature extracted is frozen, and that is like non-trainable, and is followed by dense classifier layer with 10 neurons for 0 to 9 digits. And then so this and then I pre-process the data as MobileNet V2 expects 224 by 224 RGB images. We convert the original 28 by 28 grayscale to RGB and resize them. Also normalized pixel values to the range 0 to 1. And then after that, we call model.summary. I compile the model, define the model, combine the model, and call model easy.summary. And we can see the output as well, the layers, the parameters, and then the accuracy. And then intermediate level task. Simple CNN on fashion MNIST. So as the MNIST images are 28 by 28 grayscale, so I normalize them and add a channel dimension to make them shape 28 by 28 by 1. And after that, this is a simple convolutional neural network. It has two conv 2D layers with railway activation followed by a max pooling 2D layers, and also a flatten layer to convert feature maps into a 1D vector, and two dense layers with the final dense layer using softmax to output predictions for 10 classes. And then after compiling and training and evaluating, I visualized some of its predictions, and I can see that it properly predicted the ankle boot, pullover, trouser, shirt, trouser, coat, shirt, sandal. So this is the intermediate level task, and next is advanced level task, which is multi-label classification on MNIST. In this advanced level task, simulated a multi-label classification scenario using the MNIST dataset. Like instead of single label integer outputs, I convert the labels into one hot encoded vectors. So each image has 10D label vector. I use the same MobileNet V2 model, but now the final dense layer uses sigmoid activation to output independent probabilities for each of the 10 classes. The model summary again, we can see the shape and the parameters and its accuracy as well, 0.75, and the prediction shape and the prediction sample prediction values. And the value, each value is like probability for each class. And and next is the expert level task, which is object detection with SSD, MobileNet V2. So first I download an external image of an Eiffel Tower. Using OpenCV, we load the image, convert it from BGR to RGB, and resize it to 300 by 300, which is the expected input size for the SSD MobileNet V2. And then the image is cast to uint8, and a batch dimension is added to create the final input tensor. Then we load the SSD MobileNet V2 detector from TensorFlow Hub and run inference on the preprocessed image. And instead of printing all raw output arrays, I printed a concise summary table that lists each output key, its shape, and data type. And we can see the summary as well. I mean, this summary, like it includes output like raw detection boxes, detection scores, and detection classes, which tell us the model's detection results. Finally, this is the original image I've taken. So this is my task using like image classification task using keras Hub in four different levels. Thank you.